Storage map in Sway is like mappings in Solidity. I'll give you two examples, basic and nested. For the basic, we'll take a look at how to insert, read, update, and remove. For the nested example, I'll show you how to do the same thing, insert, read, update, and remove for a nested storage map. To declare a storage map, we start with the keyword storage, and let's start with the basic. We'll create a basic storage map, so say balance of. This will be a storage map where the key is an identity and the value is some number. Say storage map, the key is identity. Again, remember that identity is like an address in EBM, and then the value will be U64, a number. And then we'll initialize this to an empty storage map. Okay, let's create another storage map. We'll create a nested storage map. Let's call this allowance. If you're coming from Solidity and if you already know what an ERC20 token is, inside it you'll know that there is a mapping called allowance, which is a nested mapping from address to an address and then to a value. Here we're creating something similar, but if you don't know what this means, then you don't have to worry about it. What I'm going to show you is how to create a nested storage map. So there will be multiple keys, and then at last there will be some kind of value. We'll create a storage map that maps from an identity to another storage map that maps from an identity, and lastly to a value. So type storage map. The first key will be an identity, and the next key will also be an identity. Now, unlike Solidity where we declare nested mapping, to create a nested mapping in Sway, what we need to do is create a key of type tuple. So the first key will be an identity. So notice here that I wrap this identity in a tuple. And the next key will again be an identity. And then lastly, the type of value. Type of value, U64. Again, we will initialize this to an empty storage map. Okay, so this is how you would declare a basic storage map and a nested storage map. Let's take a look at how to insert, read, update, and remove. So let's start with the basic example. Since we're dealing with identity, what I'm going to do first is import message sender. We'll use message sender as the key for some of the examples. So I'll import them by typing use std ::alt : message sender. We're also going to need another identity for this example, so I'll declare a constant address. Constant address B256, and the value of this is a 1, and then rest are zeros. Okay, so let's begin with the basic example. Okay, we'll look at how to insert, read, update, and remove. So for the basic example, we're going to access the storage map balance of, and again, the key is an identity. So to get the identity, we'll use message sender. Say that sender equal to message sender dot unwrap. Okay, once we have sender, we can now play around with the storage map balance of. To insert, we'll have to type storage dot balance of dot insert into sender. The key is the sender, and value, let's say 1, 2, 3. To read the value inside the storage map balance of, where the key is sender, we'll have to type storage dot balance of dot get sender. Now in Solidity, when we access a mapping, and let's say that the value at that key is not set, then it will return the default value. However, this is not the case in Sway. When we call this function, what it's going to do is return the option of value. To show you this, let's say that val is equal to U64. Now it's not equal to U64. Let's just type this out and we'll try to compile it and see what kind of error message we'll get. Inside my terminal, I'll type fork build. And notice here that we get an error message. We declare val to be U64, but the return value of storage balance of get is option of U64. And what does this mean? This means that if there is no value set inside the storage map balance of for the key sender, then this option U64 will return a none. Otherwise, if it is set, then it will return some with the value wrapped inside. So back inside the code, this part is returning the option of U64. To get the actual value U64 wrapped around the option, what we need to do is call .onWrap. And let's say that there is no value set for sender. Is there a way to return a default value? Well, we can do this by saying unwrap or 0. And to show that this now works, let's open the terminal again, compile the contract, and the contract compiles. Okay, let's go back. So how do we update? Well, to update, we'll do the same thing as insert. Storage balance of insert to sender, bow. The current value is stored as bow. And to this, we put in some number. Let's say +1. And then if we wanted to remove the value, we would type storage dot balance of dot remove sender. Okay, so this was a basic example of insert, read, update, and remove. Let's move on to an example of nested storage map. So again, I'll show you examples of read, insert, update, and remove. For this example, we'll use message sender for identity again. So say that sender equal to message sender dot unwrap. Since for this example, we're using a nested storage map where the keys are identity and identity, for the second key, what we're going to use is this address. We'll need to wrap this address into an identity, so say that spender equals identity address, and then address from ADDR, the constant that we defined above. Okay, so let's start with how do we get the value. Say that val equals storage dot allowance dot get, and the key that we'll need to specify is a tuple. The first key is sender, and the second key is spender. And like this example over here, to get a default value, you'll need to type dot unwrap or 0. So this is an example of read. Let's move on to insert and update. So again, to insert, it's similar to the basic example. What we need to do is call insert. The key will be a tuple again. And let's say the value is the current value, val, plus 1. This insert should be an insert lowercase. Okay, lastly, to remove a value using a key, we'll do the same thing as over here. I'll copy this, paste it here. The storage mapping that we're using here is allowance, remove. The key is 2 parts. It's a tuple of the first being an identity, sender, second being another identity, spender. And that completes the example for nested example. Let's try compiling this contract. I'll open my terminal, clear the logs, and then type fork build. Okay, and our contract compiled.